All right, let's talk about Lewis structures. The shape of molecules, the general shape of a molecule is represented by a Lewis structure. So I'll let you pause the video and read these steps yourself. I don't need to read it to you. These steps are also listed in the notes. Calculate valence electrons, make a skeleton, give everyone an octet, extras go on the central atom, form double and triple bonds only if needed, and then don't forget brackets around ions. So let's do this one together. Draw the Lewis structure for chlorate, ClO3-. So, least electronegative atom that is not hydrogen. Electronegativity increases across a group. So if you're going across, electronegativity increases and it decreases going down. So chlorine is less electronegative than oxygen is. So chlorine is going to be our central atom. But the first thing we need to do before we get to that is we've got to calculate the number of valence electrons. So chlorine is in group 7, oxygen is in group 6, and then we've got to add an electron for the charge. Right? So 7 plus 18 plus 1. So we've got 26 valence electrons total. Now the least electronegative atom is the central atom. If you're looking at your periodic table, just make a note to yourself. Electronegativity increases across a row and decreases down a group. So we want to pick the least electronegative element, so that would be chlorine. So we're going to put chlorine as our central atom, and then we're going to attach all our other atoms with single bonds. Each single bond represents 2 electrons. So we had 26 that we needed to represent. We've represented 6, so we've got 20 more to go. So we're going to give all our outer atoms octets. So that'll make our Lewis structure look like this. And then we've got 2 electrons left over. Right? We've got 24 represented. We need 26 to be shown. So we've got 2 left over. So those leftovers go on the central atom. And now you make sure that everybody's got an octet. Chlorine sees 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And because it's an ion, we put brackets around it and write the charge. If this were not an ion, we wouldn't need those brackets, but because it's an ion, we do. All right, the next example I want to talk about is HCN. So hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. So my total is 10 valence electrons in my Lewis structure. So carbon's going to be my central atom because hydrogen can never be the central atom. And if you're looking at the periodic table, electronegativity increases across a row. So that means that nitrogen's more electronegative. So we don't want it to be the central atom. We need it to be the least electronegative atom. So that makes carbon our choice. So here's our skeleton. Right? We've got 10 valence electrons that we have to work with. When we make our skeleton and give our outer atoms an octet, now hydrogen's an exception, right? It doesn't need an octet, it just needs 2. 2, 4, 6, 8, 10. Okay, we're out of electrons. But carbon doesn't have an octet. So what we're going to do, is we're going to take this pair of electrons and dump it right here. Take this pair of electrons and put it right here and form a triple bond. So you only form double and triple bonds when you're out of valence electrons and the central atom doesn't have an octet. You never form double bonds just because they look cool, right? You only do them out of necessity. And then from here, I highly encourage you to download the problems from the internet on D2L or do the problems from the textbook that I've suggested, and practice is key to getting good at Lewis structures. But those are the basics of how we draw Lewis structures.